The diagram above shows part of the curve C with equation y equals f of x, where f of x is equal to x cubed minus 6x squared plus 5x. The curve crosses the x-axis at the origin and the points A and B. Part A, factorise f of x completely. Well, I can see that we've got an x in each of these terms, so I can factorise that out first. So that will leave me on the inside here with an x squared minus 6x plus 5. I can now factorise that quadratic. It's going to be x minus 5, x minus 1, because the minus 5 times the minus 1 gives the plus 5. The minus 5 plus the minus 1 gives the minus 6. This has now been factorised completely. Part B. Write down the x-coordinates of the points A and B. Point A and point B are the roots where f of x is equal to 0. And I can see that I've got that from, we've got the 0 from here, we've got a 5 from here, and we've got a 1 from here. So the x-coordinate of A must be 1, the x-coordinate of B must be 5. Part C, find the gradient of the curve at A. So gradient makes me think the gradient function. So I want to differentiate here. So I need to take my function, the y equals x cubed minus 6x squared plus 5x, and I want to differentiate that to get the gradient function. X cubed differentiates to be 3x squared. Minus 6x squared differentiates to be minus 12x, and the 5x will differentiate to be 5. At point A, when x equals 1, the gradient then is 3 times 1 squared minus 12 times 1 plus 5, which is 3 minus 12 plus 5, which is minus 4. So the gradient of the curve at A is minus 4. We are then told that the region R is bounded by the curve C, the line OA, and the region S is bounded by the curve and the line AB. Use integration to find the area of the combined regions of R and S, so shaded in the diagram above. So for region R, I can find region R by integrating to work out the area underneath the curve between 0, that's my lower limit here, and 1, that's the upper limit there. So x cubed is going to integrate to be a quarter x to the power 4. Remember, to integrate we add 1 to the power and then divide by the new power. So add 1 to 3, you get 4. Divide by 4, we get a quarter. Next, add 1 to the power of the squared, we get cubed. Divide by the new power. So 6 divided by 3 is 2. The 5x will integrate to be 5x squared, add 1 to the power, divide by the new power. Between the limits of 1 and 0, so we're going to substitute 1 into this. We would then substitute 0 into this and take them away. Substituting 0 into all of those terms will give 0. So this is going to give a quarter minus 2 plus 5 over 2, which will all simplify to be 3 quarters. So the area of region R is 3 quarters. We're now going to do the same thing for region S. important thing to bear in mind here is that S is below the x-axis. Therefore, it is going to give a negative answer. That's why we have to do these things separately. You can't do it all in one go. Even though the calculations are very similar, because for region S, we're still going to be integrating the same curve because we're still working out the area between the curve and the x-axis. So we're still integrating the same curve, but this time our limits, our lower limit is 1 and our upper limit is 5. So we're still integrating, so we're still going to get the same result. This is 3x, a 2x cubed, wasn't it? And a 5 over 2x squared. So we've still got the same thing here, but the important thing to note is that when we substitute our limits in now, so 1/4 times 5 to the power 4 minus 2 times 5 cubed plus 5 over 2 5 squared. So that's substituting in the 5. We will now substitute in the 1 and take them away. So we'd substitute the 1 in as well, so 1/4. So this is substituting the 5 into the function. This is substituting the 1 in, and then we take them away. Substituting 5 into the function and then substituting the 1 into the function, taking those away. So I'm going to substituting the 5 into the function. I get minus 31 and 1/4. That's the answer to this. Substituting 1 into the function, I get 3/4. So that is this. And now I have to take them away. So combining those two things together, I get minus 32. So therefore, that's the area underneath here. The area of S underneath is 32. The minus, like I said before, is just telling me that it's below the x-axis. The actual area is positive 32. The minus is just telling me it's below the axis. Therefore, total shaded is 3/4 the region of R plus the region of S, which is 32. So we get 32 3/4.